Okay, so we're continuing with this idea that's a little bit complicated and it's a little bit circular, that integrals are the same as antiderivatives. The integral of f of x gives the function capital F of x, and the derivative of capital F of x is capital F prime of x, which is little f of x, which is the slope of f of x. So basically that there's a relationship between slopes and antiderivatives and integrals, and that's what we're trying to tease out. Okay, so let's look at a function. This is going to look a little bit funky. So we got this function y equals x cosine x squared. And let's just zoom in on this portion right here. Okay, so now we haven't really gone into it just yet, but in the next chapter we'll figure out that you could do an integration by substitution, and an integration by substitution is going to show you that the antiderivative of this function here is going to be 1/2 sine x squared. Okay, so now what I want you to do is, I'm saying that this function is the antiderivative of this function. Now we haven't really learned how to show that yet using integration by substitution, but you should be able to take the derivative of this function and get here, because this is just a chain rule. So it's derivative of the inside, which is 2x, times 1/2 gives you your x, times the derivative of the outside, sine x squared, gives you cosine x squared. So now if I graph those two together, well, I'm saying that my original function is the derivative of the red function. Purple, let's call it blue. Blue is the derivative of red. So where blue is equal to 0, red should be horizontal, and it is there. And right there, where blue is equal to 0, red should be horizontal. Where blue is equal to 0, red should be horizontal. Now where blue has a maximum value, red should be as steep as it ever gets. And that's true there. And then where blue has a minimum value, it should go slope downward as steep as it gets. And it does. So the point is that I want to make is that the integral of the blue is the red, and that also the derivative of the red is equal to the blue. So integrals and derivatives are basically running in opposite order. Okay, but now in the previous video, I'm a little bit off task here, because in the previous video, what I really wanted to talk about was slope fields. So what we're really talking about is slope fields. So f of x generates a slope field. Well, how am I going to do that? And I promised that I'd do that on my calculator. And so it's a little bit complicated how I have to do that on my calculator. I've got to make a 2-vector. This is just how the people who programmed the software wanted me to do it. So there's my dy dx. It's actually right now, it doesn't look like dy dx. I apologize, that's just how they want me to type it in. And so I'm going to say that my dx is 1, and my dy is going to be this function here. So my x cosine x squared, I'm going to plug that in for my dy, and I'm going to turn that off, we'll make that blue, and we're going to graph it. Okay? So there's my graph. And if I zoom in a little bit, it looks like that. So it's a slope field. So basically what I've done is if I turn on this one, you see that I'm using the red to generate little arrows just like I did manually in the previous video. And so right at this point in time, the red is telling me that the slope is 0. So I've made all these little horizontal lines at where the red equals 0. Here the red is also equal to 0, so I've drawn all these sort of nearly horizontal lines. And then here I've said that the slope is like 0.6, so I've drawn all these little arrows that have a slope of 0.6. So these blue are basically just translating the y values of the red into slopes. Okay? Now, let's turn off that and let's just look at the slope field. Let's turn on this function here. And you'll see that this function does what I was trying to do manually before, which is it starts here and it's going horizontally, but then it goes up a little bit. And right here, it's paralleling this little vector. And then here, it's paralleling this vector. And here, it's paralleling this vector. Here, it's paralleling this vector. So basically, it's following the slope field. It's going up, and then it maxes out, and then it comes down. And then it bottoms out, and then it comes back up. But now, as I said in my previous video, I could do it. I could raise it up, or I could lower it down, and I can sort of, this will take a little bit of you getting used to. Again, I just know how to use the software. I can slide it so as I have different values, so I can have y equals 1/2 sine x squared plus c, and I can change that c, and so the derivative of all of these green functions, no matter what the value is I have for n, the derivative of all of these green functions is equal to the red function, or looking at it from the other way, the antiderivative of the red function gives me all of these green functions. So I can translate the green function up or down vertically, and the derivative of that is still going to give me the red function, or the antiderivative of the red function is going to give me any and all of these translated green functions. So that's why we always have to put plus c on the end of our integrals.